Okay, so one, I think, last thing I'm going to talk about is levels of processing. So I want to distinguish between something called bottom-up processing versus top-down processing. And what these refer to, so bottom-up processing, why we're talking about levels is often we think of the sound signal, like what's actually coming into our ears, is the lowest level of information we have. So bottom-up processing is any sort of processing where we just use the sounds we hear. So whatever comes into our ears, that's what we use. However, we can contrast this with top-down processing, which is when we use other knowledge apart from what's in the acoustic signal, linguistic knowledge or real-world knowledge, to inform our processing. So that's actually sort of a broader concept in psychology. And if we break that down to speech, we can think of bottom-up information as the sounds we hear, and then the top-down information is linguistic knowledge or real-world knowledge. So again, bottom-up processing, we have our sound wave, and we can break that down into phonemes as it comes into our ear. My name is Jessamine, right? And this is sort of like very intuitive. We hear sounds across time, although remember there's a lot of overlap between sounds in real speech. Some evidence for the fact that we use bottom-up processing, well, we can understand words we've never heard before. So if I say Banik, you know what I'm saying, even though that's not a real word. You can write it down, you can repeat it after me. Also, we have to use bottom-up processing when we're not sure what we're going to hear, right? So like, if I just say a random word like hoist, there's no way you could have guessed that I was going to say that. Well, not much of a way you could have guessed I was going to say that, but you can still hear it and figure out what it is. However, top-down processing is also a thing because there's other information that does affect our perception. So linguistic knowledge affects our perception and also real-world knowledge. And we can perceive the exact same sound differently based on context. And one good example of this is the Ganong effect. And what this means is if the sound is ambiguous between two sounds, it's likely to be perceived as whichever sound will make it create a real word. So that's sort of confusing as a definition, so I'm just going to give you an example here. It's not that hard to understand. So let's say we have this question mark sound, not a glottal stop, question mark, which is an ambiguous sound somewhere between, it's sort of between G and K, between gut and ka. Okay, and let's say that I put that sound, I splice that sound onto the rest of a word. So you have this word gift, which is right between gift and kift. Well, which one are you going to hear? What do you think? So most people are going to say, well, people are going to hear gift. Now, note that if I say kift really carefully, you're going to hear kift. It's not like you can't hear a non-word. But when something's ambiguous, you might be more likely to hear it as gift. In this case, are you more likely to hear gis or kiss? Well, you're going to be more likely to hear kiss in this case because kiss is the real word. So the point here is that the exact same sound, so the exact same acoustic information, can be heard differently based on our lexical knowledge. So the same sound will be heard as G if it's heard in gift, or as K if it's heard in kiss, due to our lexical knowledge. And so that's one example of how linguistic knowledge can affect things, and so can our real-world knowledge. So taking the same example, if we have that ambiguous sound between gut and ka, if you have it in a sentence like the girl milked the goat versus the girl put on her coat, you're going to be more likely to hear it as a G in the first sentence because it's going to make the word goat, but as a K in the second sentence because it's going to make the word coat. And it turns out, I actually did some research on this myself, it turns out that people are more likely, as you would expect, to hear it as G in the first sentence and K on the second sentence. Again, point being that the exact same sound is going to be interpreted differently based on something else, in this case, your real-world knowledge. Okay. So one thing that's good to think about in terms of top-down processing is that automatic speech recognition uses a lot of top-down information. So you might think your phone's really good at understanding your speech, um, and it is. And part of the reason is because it uses a lot of predictive power. So it might hear something like, let's meet for dinner, but it's going to understand or it's going to output let's meet for dinner because it knows that let's meet for dinner is a very unlikely thing to be said. So actually, automatic speech recognition isn't that good. It's not as good as humans at actually recognizing sounds that are said, but it uses a lot of, it's been trained on a whole bunch of data, and so it can use its knowledge of what's likely and unlikely in order to make really good inferences about what was said in combination with information from the acoustic signal. Okay, the best example of top-down processing, definitely the most fun, is called the McGurk effect. And this one, you have to see it to believe it. And so you should go and watch this if you haven't already. It's linked on Quarkus as well. But it's a demonstration of how our perception of sound is affected not just by what we hear, but also by what we see. Okay, so why study psycholinguistics? Well, all of these sort of insights that we've found, these little bits of empirical information that we found out from these experiments I've been talking about, we can put those together to create models of how we process language. And we can test those out both computationally and by seeing how well they match human behavior. And our goal is to create a model that best simulates how humans process language. And a good model is, number one, it's going to be good at the same thing as humans are good at, and it also crucially should make the same mistakes as humans make. And this is really the challenge. And building a good understanding and a good testable model of speech processing is definitely a work in progress, and it's the subject of a lot of really interesting work right now.